Okay, I have selected some. Like first, let me show you one question paper so that you will be clear how probability theory works. Like for example, I'm showing randomly a question paper. Mm, okay. See, for example, this one. Okay. So just a minute. Yeah. So you can see this is exam session one of June 23, 2023. You can see one question was from problem one from like normal sets of question like set theory, independent events, then intersection, union, all these concepts, fun question. Second question you can see here, like sorry for the mess. Let me, yeah. If you see this question, like there is a one bag here, one more bag here, some number of balls are here, number of balls are here. So it's a conditional probability question. Conditional probability question. So first one was set theory question and second is the conditional probability question. These two questions are extremely easy because they are like school level. Mostly if you know the basics of set theory, union, intersection, then what is like how the set theory works like that. So after that, we have question like this. This is of we will study about probability density function and probability mass function when we will study continuous probability and discrete probability. Okay. So what is continuous probability? What is discrete probability? This one, after this, we have to go everything in detail, how everything works. Then the last question, like this was a exam partial no, this was a exam question I'm showing you. So the last question you can see is basically a mix of question, like where you have to use two probability continuous function at a time. We will see all these things when we will study all these concepts. And this and and the last there will be six questions. So two questions are extremely easy. After one like two question from continuous and discrete probability, and the fifth question, it will be something related to stochastic concept, and also like distribution of sets and all. See the last one, you can see, as I said, the last question, it will be a stochastic process. It will, the condition will be given to you. So you will, when you will study, you will get to know. Just a minute, I think, let me admit. Yeah. um did he join?
Can I disconnect and be connect with my laptop because in my phone it's very little the
Okay.
screen.
Yeah, yeah.
Okay. Okay.
Disconnect.
So I will. Okay.
Hello.
Hi.
Hi.
We were just waiting, like we were just discussing about the question paper, how the pattern will be, probability, full exam question paper. Like we were waiting and discussing. I think Gorda Ferret is going to join in one more device. Uh,
Okay. Okay, it's okay.
so yeah, let me recap what we did. Like I was discussing that problem one
Mm-hmm.
and problem two of probability question will be very easy. Like mostly set theory and all, union, intersection of sets. And then problem two will be from conditional probability based theorem. these two, and multiplication rule. These three things you know, question 2 will be solved. And rest will be from continuous and discrete probability, and from stochastic processes. When we will study that, we will see.
Okay.
So
I
now let's go to the basic theory. I have selected some questions we will do today only, so that you will be very clear with the concepts. But before going to the question, let me just discuss about the very
Sorry,
basic
can you hear
concepts
me?
of. Yeah, yeah, I can hear you.
Thank you.
Okay, so you know what is a probability theory? What is probability theory? It's most based on theorems uh, and lemmas, lot of like I we say axioms, theorems, all these things we study in probability. But what is probability? It means the possibility of outcome. Like for example, for example, in a box there is five red balls and two green balls. So what is the probability of getting green ball? We know it's 2 by 7. Total number of balls are 7, and probability of getting green ball is 2 by 7. So this was the basic concept how the probability works. Let me go to. Okay. Do you know what? Let me give you the definition of probability space. Okay. So probability space. Let me represent probability space with psi. Okay. And so what is the definition? The definition will be the probability space psi is a triple where psi equal to omega, f, and p. What is omega? Where omega is a non-empty set of points or outcomes called sample space. So we will see what sample space is. Okay, and what is F? This one. This is the family of subsets of omega. Family of subsets of omega. Omega is the sample space. We will see what is sample space. And what is P? P is a map. It's basically a probability. Okay. P is a small probability, which is a map from F to into R. That satisfies axioms of a positive measure of total mass equal to 1. What does it mean? For example, like as I was giving the example of that, like there is a bag and it has five five red balls and two green balls. Okay, what is the probability of getting, like, not even the whole total probability? What is the total probability? It will be 1. The maximum probability can be 1. What is the probability of red ball? P red is 5 by 7. What is the probability of getting green ball? Is 2 by 7. Okay, so what is the sample space? Sample space means all possible events can be occurred in experiment, like all possible events of an experiment. So what are the possible outcomes of the experiments? Imagine this is our experiment. So what are the total possible outcomes? We have only two possible outcomes. Either we get red ball or we get green ball. Okay, so these are our, so what will be the sample space? All total possible outcomes is the sample space. Okay. Okay, I would like to ask, do you have any idea about set theory? Like, what is A union B? Probability of A union B. That is probability of A plus probability of B plus. Do you have any idea?
Minus the intersection of A and B.
Yes, yes. So you know the basics. Okay. So let me just recap it. Then what will be this one? For example, there is a set EFG. So E intersection F union G. What will be E intersection F? I can apply the distributive law and write E intersection F union E intersection G, right? And let me also, do you know about this rule? This is distributive. And there is a, let's say there is a set E and F. So E intersection F complement. What can I write? E intersection E complement union F complement. So this is De Morgan's law. De Morgan's rule. So one more also, E union F whole complement. I can write. Just change this intersection to union. Union will be changed to intersection. E complement intersection F complement. So this is also De Morgan's law. Okay. So you know all these concepts. Let me also write one more. Let me write this 1, 2, 3. So E union F, can I write this E given F union E intersection F union F given E. It can be also written as E intersection F complement union E intersection F union E intersection F. E complement intersection F. If you cannot understand this one, just see the diagram. This is set E and this is set F. Okay. So what is this part? Just this part. This part can be written as
E without F.
Intersection F complement.
C.
Right? Everyone is able to understand?
Yes.
Okay. So this part will be E intersection F and this part will be E complement intersection F. So you can now see this. So what will be the total part? E intersection F complement union this, union this. Okay. Next we go to one more small theorems, like just we have to discuss and then we'll go to the question.
For the E part, for the first in the left side, we can say that E minus
Yeah, you can also write like this
and
E minus F. This is E minus F. This part. I mean this part. You can also write E minus F. And this one also, this part. Let me use one more color. Just this part, not including the middle. This part you can write F minus E.
And I thought
Like there,
we can
sorry.
also write E minus F intersection E or E intersection F because
Yeah,
that common
there are
part
many,
in the middle.
that can be also written. There are many ways to write. I just wrote, like, showed you one representation. You can also
Mhm,
write E, then union F minus E. Also, you can write F union E minus F. It's the same.
mhm. So why we can in the again that question I couldn't actually understand. E
Which question?
intersection F complement. F complement means the opposite of F, right?
Okay, let me tell you. F, for example, this, imagine this is the whole space, and you have a set. This is F. All the possible experiment, everything is there in the set F. So F means inside all this, inside F. F complement means outside F.
Mm-hmm.
Whatever is there outside F. So this is F complement.
Mm-hmm. Okay, I understand now. Thank you.
Okay. So let me go to one or two more like formulas. So F is a E is a subset of F. So E is a subset of F means what? Inside F, E lies. This is E. So can I write this probability of E will be less than equal to probability of F? Okay. I am not going to all the proofs, just know the basic things. These are very basics. And one more I am writing D. So 0 probability of E must be between 0 and 1. The probability always, the maximum value will be 1. Then probability of E union F, as I have just said before, probability of E plus probability of F minus probability of E intersection F. If
Yeah.
there is no intersection, okay, you wanted to say something?
Yeah, I wanted to say that if there's any possibility that you can provide for us the proof of all of these, if we are not going through them in the class, but we
Yeah,
have some.
after the class in the evening time, mostly in the night, before night, the notes will be shared. Like every after class, every notes will be shared to you. Like notes and everything, question notes, everything will be shared.
Actually, I have a problem to prove that. Yeah, could you please go a little up a screen, scroll the screen?
This
Part
part,
C. Yeah, part C.
see
When
this one.
yeah, I think the
Okay.
proof of this is a
Okay.
little difficult.
Basically, we will not waste time in proofing because proofs are not asked in the exam. But for knowledge, like we will share you the notes with proofs and everything. You can go through the notes, and if you have doubts, we can discuss in the class. Is that okay? But if you
Yeah,
are
okay.
asking about this proof, let me prove this one for you. Okay.
If it's
So,
not
for
gonna be in
example,
the exam, it's fine.
yeah, not gonna be in the exam. So you can write F, it can be written as the whole set F can be written as F intersection E union E complement. Can I write like this? Because
Mhm.
complement means outside. So outside of E, so I can write like this F intersection this.
Mhm.
So I can also write F intersection E. I will apply the distributive property which I told F intersection E complement. So I can write now E union, because F intersection E will be E because this is the smallest which is lying inside the subset of F. So it is a subset of F. So it will be E union F given E, right?
Mhm.
Can I write this one into this? So now
Mhm.
from this, you can see that whatever the probability, so how will you prove this one? Let me go here. So we got we got F equal to E union F given E. So from this, E intersection F given E, what will be the outcome of this?
E.
If it is a disjoint, for example, there this
It's
is F, this is E.
0.
0, 5, if it is disjoint.
Mhm.
Okay. So, for example, the probability of F. What can you write the probability of F? It will be probabilities. Look at this formula and just say it will be probability of E plus probability of F given E. Just look at this formula. Probability of F, E, this will be plus probability of F given E. So this probability will be obviously greater than the probability of E, right or wrong? Because there is some
Yes.
extra thing added, extra probability which is added with probability of E. So obviously this part will be greater than probability of E. So from this you can say that probability of E is less than probability of F. Did you get the point?
Yes.
Okay. So like this, all the theorems and formulas I will share you. You can read through the notes because everything will be written and you can understand everything. We don't have to waste time in proofing every formula because these are not important for exam. We will just apply the formula in the exam. Okay. So next one I am writing F. So this one I was telling you. For example, if E intersection F is phi for disjoint, then P F union will be P of E plus P of F. Okay. And probability of E union F must be less than probability of E plus probability of F. Okay. And let me give you one more formula also. Probability of E union F union G equal to probability of E plus probability of F plus probability of G minus probability of E intersection F minus probability of E intersection G minus probability of F intersection G plus probability of E intersection F intersection G minus the common ones. So E, F, G. From this you can see this part, small part will be added and these parts will be subtracted, you can see. And rest parts will be added. So this is the formula. Let me also give you one important formula, H. It was P of E. This is called triangle symbol. If we have this, P of E plus P of F minus 2 times P of E intersection F. This is the formula. Whenever you have like this, then it will be E, F. So this will be 2 times. So that means you can also write that is probability of E minus F union probability of F minus E. Just this part will not be included. This part will not be included. Okay. Let me go to some other. We will now go to mostly conditional probability. And do you also know, for example, there is like, for example, there are n objects, they are different, distinct, and k times, so they are taken k times. Okay, okay, so there are n number of objects inside this bag. Okay, n different objects, and k times we have to draw without repetition. So k times we have to take out one ball, then second, like this, k times. So what will be the composition of this composition? It first, for the probability of first time will be n variety, because we have n number of different ball. The next time, one ball we have already taken out, now we will have n minus 1 variety. So into n minus 1 into n minus 2 up to n minus k plus 1, right? So this is the dispositions depositions. For example, if we have for example, if k equal to n, that means they are same. For example, 5 distinct objects are there, and I have to take out 5 times. So it will be n into n minus 1 into n minus 2 dot dot dot, this n equal to k. So it will be up to 1. So this is what? N factorial. Okay. Now, what will happen if we are going without replacement? With replace, this was without replacement. If I replace, for example, if I take one ball out, then keep that ball. I take out and then keep. So it will be n into n into n into n up to k times. Okay. And one combination formula you might have studied in school, NCK, which is n minus 1 up to n minus 2 up to n minus k minus 1 divided by k factorial. This you might have studied in high school. It can be also written as CNK equal to n factorial divided by k factorial into n minus k factorial. Okay, this is the formula. We can also represent nk like this. Okay, then
When we use this combination, when it is without replacement
for
and
example, no, with and without, both cases you can use. For, like, for example, question like this which I gave the example, there are n number of balls, and with for example, without replacement, this is without replacement. So you don't have to replace it. Once the ball is taken out of the bag, it's thrown. Imagine like that. So first, how many options you have? N number of options. Second time, you don't have n number of options. One has been already taken. So it will be n minus 1, n minus 2, dot, 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 up to n minus k plus 1 options. Okay. And for example, if there are 5 balls, I'm taking 5k, and you have to draw it 5 times. K is the number of times we will take out the ball from the bag. This is without replacement. We are not replacing the ball again inside the bag. So now you will take out 5 times 5 balls. So first, how many options you have? 5. Okay. Second time, how many options you have? 4, 3, 2, 1. So this can be also written as 5 factorial. 5, what is 5 factorial? 1 into 2 into 3 into 4 into 5. So that if I was applying with replacement, I take out one ball, keep it inside the bag. So it will be, so how many option I will get? There are 5 balls and I have to take out 5 times. So first time will be 5, second time will be 5, third time will be 5, fourth time will be 5, fifth time will be also 5, right? Is that so? Everyone understood this one? This
Yes.
concept? Okay.
Yes.
When we will do the question, you will be more clear about it. Okay. And one more property I'm also saying you. N, this is nk, this one, nk is also equal to n minus k. Okay. When you will get the proof also how it is equal. Let me show you now only. N minus k. I can write this one. This one. I'm writing. Can I write n factorial by n minus k factorial divided by, see, the upper one is n factorial. The down part will be n minus k factorial. N minus k factorial. Because n minus k, the formula is, so upper minus lower. So this one will be n factorial divided by n minus k factorial by k factorial. Okay. So this and this you got the same. This part is equal to this part. So it is proved. Okay. Let me go to one more. Okay, now let's directly jump to conditional probability. Conditional probability. So what is conditional probability? Any condition is given to you, any conditions or something is given. What is the probability of getting A event condition that we have B event, B as the outcome? Okay, so this is some condition will be applied and then what is the probability will be asked. So for example, I am giving an example. In a bag, okay, in a urn, there are 80 black balls else and 20 red balls. Okay, and we have to draw 2 times without replacement. We don't have to replace the ball after drawing it. So what is the probability of getting the red ball twice? A red ball twice. So first one, red ball in both draws. So 2 times we will take out from the bag. So what is the probability of getting the red ball 2 times? So what is the first probability? So we can write probability of the, let's say, distribution of, we get the first one red, intersection we also need the second one to be red, d2, draw 2, so draw 1 red and also and draw 2 red. That means draw 1 red, how many balls we have? Total number of balls, total balls is 100. 20 red balls, so it will be 20 by 100, first one, without replacement. So how many balls, red balls are remaining? 19. So 19 by, okay, what is the
99.
total number of balls now? 99. So 99. Okay. Now what is, if I ask one more question, like what is the probability of getting the red ball just in the first draw? What is the probability of getting a red ball? Option B is red ball in first draw. Second draw, I don't care. Okay. So what is the probability? Probability of draw 1 red will be, first time I take a ball, red ball. So what is the probability of taking red ball in the first? It will be 20 by 100. I have to take the second time, I have to draw the ball, 19 by 99. Right?
You said the
Is
first
it?
ball is only red. The second, it
Yeah,
doesn't matter what is
second.
it. So why is it
Yeah, second
19?
doesn't matter. 19. Let me show you. First one should be red. Okay. First one should be red. Second one, it can be red or can be black. Okay. So first one I took red. I have to draw two times. So two times I have to draw the ball. So first time I got red. I have to count for red. So first time there are 20 number of red ball out of 100. Second draw, I have to consider also because I have to take the second one. But it is not said that you have to consider red or black. Anything I can consider. So I consider second draw is also red. So now I will get 19 out of 99. You will say not only this condition, what will happen if I take the black ball out? Yes, this can be also condition, or there will be a or. It can be. So my first draw is red, 20 by 100. Okay. Or then second one is black. Now I have 80 black balls out of 99 balls. Understood the point? Now
Yes.
you just calculate this and it will be done. So this is first condition. This is condition number for red ball in second time. This is black ball in second time. You have to always consider the conditions. Okay, this is all about conditional probability. Okay. um, Let me also same question. I'm giving one more example. What is the probability that the second ball will be red subject to condition that the first ball is red? Like my first ball is already red. I have already drawn my first ball and it got red. What will be the probability of the second ball to be red? I'm
Divided by
writing
99.
probability of draw to red, given that, whenever I say given that, you have to apply like this condition, D1 is red. So what is the probability of getting the second ball to be red and the first ball is already red? So you can think, if the first ball is already red, that means how many balls? One ball,
19.
19 balls are there out of 99. So it will be 19 out of 99. You can do it like this by applying your logic, or else you can also apply the formula. That is probability of D1 equal to red intersection the draw 2 is red. Okay. Divided by probability of D1 is red. I will give you the formula. Uh, if I ask one more question, what is the probability of second ball which I draw is red given that the first one is black? First one I got black. What will be the probability of second ball to be red? First one, if I got black, it will be 80 out of 100, right? But what is the probability of getting the second ball to be red? It will be, I have 20 number of red
20
balls.
out of 99.
Perfect. 20 out of 99. So you can apply logics and then you can just solve the question. These are very easy question. You will get similar question like this in the exam. So I'm giving you the formula. The formula will be something like, if there is a set E and F. So E given F, it can be written as probability of E intersection F by probability of F. This is the formula. What are the conditions? The probability of F given, sorry, E given F, this probability must be between 0 and 1. Okay. Then second condition, if E intersection F is pi, what if they are not joint events? They are like disjoint. Then probability of E given F will be 0. If you apply, put 0 here, it will be 0. Then third condition, if P of E is equal to 1, then what will be the outcome? If P of E is 1. So 1 intersection F will be 1. So what will be the outcome you think? So P of E given F will be also 1.
I didn't understand C part, last
No,
part.
I said what will happen if the probability of E is 1. So put, if probability of E is 1, then what will be the probability of this one?
The intersection would be F, and then it's PF divided with PF. It is 1, right?
Yeah, it will be 1.
But is it correct that the intersection between PE and
No, no.
F, because
Listen,
PE is 1,
if P is 1, so it is the maximum value. That means the
yeah,
intersection will F
will
will
be the F.
be E intersection F will be what?
F.
F.
Mhm.
So divided by P of F. So what will be this?
1.
This is 1. Okay. Okay, so these are the theorems, and let's, I'm thinking what, yeah, now let's go to Bayes rule. Okay, and one more also, P of E intersection E complement given F. So what you can write this one? 1 minus P of E given F. This is one more formula. Okay, so if whenever you don't understand, you can draw the Venn diagram and think this is E, this is F. So E complement part means excluding the E parts. Intersection F part is, so you can apply the Venn diagram to understand, or else you can also solve it. Okay, this is the formula. I'm giving you the multiplication formula. So, for example, if both of the sets, the probability of both of the set E and F, they are greater than 0, they can be not 0. If they are not 0, it cannot be applied. So, both should be greater than 0. So, we can get probability of E given F. I can get probability of E intersection F divided by P of F, and probability of F given E will be probability of A intersection F divided by P of F. Okay.
The second one, isn't it divided by PE?
Sorry, PE. Yeah. P. Okay. Then from here only you can also write E intersection F is P of anyone, you can write E given F times P of F. This one I am writing. Okay, is equal to P of F given E times P of E. Can I write the same thing? This part.
Mhm.
This one can also be written as like this. If I take here, multiply this one here, same thing, right? I multiply E with this one, so it's the same one. I got the PE intersection E. Okay. This formula is important. We will apply in the question. And okay, the last one. Law of total probability. Law of total probability, what does it say? It says that there is the probability of E, okay, is equal to probability of E intersection F plus probability of E intersection F complement. Okay, probability of E given F, it can also be written as, can I write probability of E intersection F as E given F times P of F. Can I write this part as probability of E given F complement times probability of F complement? Right? See this one. What can you write here? Probability of. Did you understand this part?
And no,
This part? Okay.
Not
the
really.
part of PE, law of total
Okay.
probability, I didn't
For
understand.
example, what do you write for this one? Just tell me. P of E given F. Apply the multiplication rule. Just now I taught what is multiplication formula. This one. These two formulas. Okay. So what can you write here? P of E given F. Can I write P of E intersection F divided by P of F? Right?
Yes.
Okay.
Yes.
So can I write P of E intersection F as P of E given F times P of F? Okay.
Mhm.
So what do I write for this one? Let me show you this part. Let me use one more color. P of E given F complement. How can I write this one? If I apply the multiplication formula, can I write P of E intersection F complement divided by P of F
F
complement,
complement. Mhm.
right? So can I write like this the formula P of E intersection F complement is P of E given F complement times P of F complement, right?
Yes.
Yes.
I just took this one, this part.
Yeah.
It's multiplied, you will get the same thing. See here, this part, if you see, the intersection part is equal to the conditional probability of this multiplied by the F complement. It's the same thing which we got here. Okay.
Together they make the whole space um, of
Sorry,
the
you
probability.
okay. Did you get it?
Yes.
Okay.
Yes.
Now, one more concept is left. It's Bayes theorem, and then we do the question, so that you will be very clear with not only the formulas but the application part. Okay, let's go to Bayes rule. What does the Bayes rule tell me? Can anybody tell what is Bayes rule? For example, there are like many events, many for example, the what is the probability of getting red ball given that the red ball in the first draw, given that the first draw is a black ball? What is the probability of getting uh, red ball given that the second ball is a red ball? Like continuous kind of thing, chain kind of thing. Okay. What is the probability of getting the third ball given that the second ball is red? So it's like a chain. So whenever there are lot of outcomes or events are asked to find out, there we apply Bayes rule. Okay. So for example, like we have something like F. Okay, there are a lot of as I said, first ball condition given, second ball condition given, third ball condition given. What is the probability of getting the fourth ball as red given that the first, second, third are red? Okay, when all of these conditions are asked, so I represent like this: F I from 1 to n. Okay, be a partition of proportion, you can say, of omega with F of P of Fi greater than 0. Obviously, probability should be greater than 0 to apply the multiplication rule. Okay. Remember, whenever you are applying multiplication formula, always the probability should not be equal to 0, strictly greater than 0. So the probability of F This one is J given E. Okay, this is just the formula we will apply in the exam question. Fj intersection E. I am applying the multiplication formula now. Okay, multiplication formula. So what will be here? Probability of F intersection E, Fj intersection E by probability of E. This is just the formula. So can I write this one? Probability, this part I am writing. Probability of E given Fj, probability of Fj. Can I write this one? And as I said before, how to write the intersection part in conditional part. Now I write the second part, this one. Okay, as probable the total probability. Now I apply total probability. So this part, the blue part is the multiplication rule, and the green part is the total probability, law of total probability. Okay, so let's apply what is total probability of E. Okay, so can I write summation of, because there are a lot of events from I from 1 to n, j to n, or 1 to n, lot of 1 2 3 4. Okay, let me check. I wrote the present I equal to j, and j is from 1 to dot 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 up to n events. Okay, so I have to add all the events, right? From I equal to 1 to n number of events. So P of E given Fj, sorry, I'm adding from I equal to 1. So I probability of Fi. Okay, this is same as here. If you see the total probability, see what is the formula? The total probability of E. Can I write like this? Probability of E intersection F, or probability of E given F times probability of F plus probability of F given complement plus this. Okay. Let's go to a question so that it will be very clear. Let's go to the question part. Okay. Let's do question number 2 first so that it will be clear whatever we just. Okay. Read this question. We have this was exam question of full exam question of June 2023 first session. Okay, there is a on which contains one red ball and one green ball. Can you hear me?
Yes.
Okay.
Yes.
So one red ball and one green ball. So we have two bags. Imagine on A, one red, one green. Okay, and we have one more bag on B. Okay, which has two green balls and three black balls. Okay, one on is selected randomly. So now we have to select whether we will take on A or on B. Like for example, I send you, okay, you have to uh, get a green ball, so you don't know, first you have to select the on, should I select on A or should I select on B, then you will take one ball out of it, one ball will be drawn from it. Question is asked, compute the probability that the ball extracted will be green. Okay, what is the probability that the ball should be green? So I write probability of getting a green ball. So first I have to select which on I have to take. If I choose on A or B, it is not asked, that condition is not given. Just asked what is the probability that the ball is green. Okay. So you tell me which on should I select? Anyone. Probability of selecting the bag, I mean the on, will be 1 by 2, right? Let's say I selected on B. Okay. So what is the probability of selecting on B green ball? I have selected on B. So what is the probability of getting a green ball?
By 2/5.
2 by 5, right?
Yes.
Okay. So or now you will apply this condition is satisfied when on B. Okay. What is the probability if I choose on A? So condition for on A. If I choose on A. First of all, I choose on A. What is the probability of choosing the on A? 1 by 2, because there are two ons. So total. So one of the on is selected, 1 by 2. Times what is the probability of selecting the green ball inside on A?
1/2.
1 by 2. Perfect. So how to write in just like this is your answer. So it will be um, plus 1 by 5 plus 1 by 4, which is equal to 9 by 20, right? Okay, so this is your
So
answer.
the
But
formula,
I,
the formula of the P of
yeah,
G now.
formula, yeah, when you are applying, let me show you what is the formula, how can you write it. Probability of getting a green ball, you can select on A or on B. So probability of selecting the on A. Now I have selected the on A. So times probability of getting a green ball given that I have on A, selected on A, or probability of selecting on B. Okay. Now probability of getting a green ball from on B given that I have selected on B. Okay. Did you understand this part?
Yes.
Yes.
Yeah. Now just put everything. What is the probability of getting on A? 1 by 2. Green ball in on A, 1 by 2, plus black sorry, on B is 1 by 2. Choosing what is the probability of getting a green ball in on B? It is
2
how
over
much it
5.
was? 2 over 5. Okay, which is equal to 9 by 20. Now let's go to option B. I'm making it. Okay. So read this question. If the ball is actually green, okay. Now the condition is giving to you. The ball is actually green. What is the probability that it will come from A? So that means the ball is actually green. So what you will apply? How you will represent this? Probability of the ball. What is the probability saying? What is the probability that it has come from on A? So probability of A given that it's actually green. Am I right or wrong?
That's right.
Yeah. So how will you apply this? Just apply the formula.
Yeah.
Formula or your
P of
logic.
A
Anything you can
intersect
apply.
B.
We have the
It will be
probability of green. We solved it, we take it from there, and we put it in the formula.
okay. Very good. So you can also write like this one. Apply the multiplication rule. Same thing. I'm applying the multiplication rule and I'm showing you how we can implement it. Or you can also apply your logic and solve it. For example, okay, can I write this one like this? A intersection G, probability of G. Can I also write this one, this part, the numerator part, as probability of G given A times probability of A?
Yes.
So this one is probability of G. Just the base rule and the multiplication rule. Because can I, if you want, I can show you this part. Probability of G given A. Can I write probability of G intersection A intersection G is same, divided by probability of A. How can I write probability of G intersection A? I can multiply these two, probability of G given A times probability of A, right? It's the same thing which I wrote this part here. Okay. So from here you can, now what you got, G given A, I can write probability of this. Now apply, okay, what is the probability of getting green ball? We have selected on A. Okay. So what will be the probability? 1 by 2 into 1 by 2, right? Probability of selecting on A, you have already done it here, this part. So, okay. See, probability of selecting on A 1 by 2. And what is the probability of getting green ball from on A? 1 by 2. And what is the total probability of the green ball? From both, you have to see. What is the total probability of the green ball? You
We
have
solve
already done it. Yeah, we saw, you just solve it here. So this one, which is 9 by 20. Okay. If you wouldn't have solved it before, then you would have to solve it. That is probability of getting a green ball from on A times P of A plus probability of getting a green ball from on B times P of B. You would have solved this one first, then you would have put the value here. Okay. So you got the value, this one will be 5 by 9. Okay. Now go to C. We did the question. Now go to C. What the C question is telling. Use B. Use this one. Whatever result you got for B, use the B to compute the probability that the green ball came from on B. Okay. Now it's the same question, but is asking not from on A, but from B. But you have to use the B concept.
Can we say 1 minus answer of B?
Yes. Yes. Answer of B. Because probability of what is saying? Probability of getting a green, no, probability that the green ball is already there. But we have to take from on B. What is the probability of getting a green ball from a B? Right? Given that it's already green. Like we have selected that we want a green ball, but what is the probability? It will be from B. So can I write like this? Probability of B given G. So I have to use the option B, C. So can I write like this? 1 minus P of A given G. Okay. Did you understand this one or should I?
No.
Okay. How do? Okay. Probability of B given G. Can I write like this? Probability of B intersection G divided by probability of G. Sorry,
Yes.
here. Okay, here. Okay. So I
It
don't
shouldn't
know.
be probability of G given by B.
No, no, no. It should be B given G because read the question again. Compute the probability that the green ball came from B. Okay. Read this question. If you don't understand, read question number B. If the ball extracted is actually green. Okay. It is saying the ball which I'm already taken out from the bag, that is already green. The condition is already given to you. You don't have to apply that whether I will get a green or not. No probability. This is fully said that you have to get a green, but you have two bags, bag A, bag B. My ball should be green, but should it be from bag A or should it be from bag B? So it is saying the probability of getting the ball green from bag B. Okay, that means probability of B given G, that my ball is already green but I have to choose from the bag B. Okay. Did you understand this part?
Yes. I
Okay.
see.
Gurdafari, did you understand?
Yes.
Okay. So can you write this one like this from the multiplication theorem? Yeah. Yes or no?
Right now, no, but I understood 1 minus PA
Yeah.
given
Did you? Yeah. But
is,
this one I'm representing it, just
yeah.
writing it like this. I wanted to prove like this. But since we could have done it without using B also, how we would have done it without using B? Like you could have done like this 1 minus this.
Mm-hmm.
So this one already we found out from B, which is 5 by 9. So 1 minus 5 by 9 is how much? 4 by 9.
4 minus.
But instead, for example, if you were not asked to do it from using B, so
Mm-hmm.
how would have you done? Probability of getting a without using B, without
The
using
probability of
option
P
B.
intersection G divided by P of G.
Okay.
Mm.
Mm, so how will you do this question?
It's 1 by 2 to the probability of
This.
getting a green
Okay.
from the
How can you represent this one? B of P of B given G given B, right?
Yeah, G given B times
B
P of
times
B. Yeah.
green.
times P. G. So same thing here. This one will be 1 by 2 because selecting the on B is 1 by
Mhm.
2. What is the probability of getting green ball from B is how much? It was
2
3
by
by 5.
5, I think.
2 by 5.
2 by 5, yes.
Yeah.
Mhm.
And the total probability is 29 by 20, which you
Mhm.
have already found out. Okay, like this. Did you understand?
Yes.
I have one question. When
Yeah,
it
yeah.
is saying, I'm sure that I am taking the from the earned B. So how much is it is green? Can I say only the number of green? So 2 by 5, because I already know that it is coming from B. And how many green is in the B? It is 2 over 5. Or no, it's not
Okay,
correct.
you mean, for example, what is the probability of green? So you just say from the B is 2 by 5.
Yes.
Okay, but if it were, this will be wrong because uh, there is a condition that you are, first of all, its probability. So my the thing is like you have two bags, A and B. You said the probability from B is 2 by 5. It seems to be correct. Logically, it seems to be correct, but actually, it's not correct because then I will ask you, how did you know that it came from B? What is the probability of selecting the bag B? You will miss the probability since you said it is from bag B, but I said where? You show me it is from bag B. If you would have
Huh.
multiplied 1 by 2 here, then I would have thought, okay, the ball is green and it is from bag B because first you have to select the bag, then you have to select the ball because there are two bags. First you choose the bag A or bag B, then you go to choose the ball from it. Okay, so first you select the bag. Without selecting the bag, if you say just 2 by 5, it's wrong. Okay,
Okay.
it's probability. Every condition you have to keep it very carefully. That's why while doing this question, these are very easy question, but you have to read the question many times to understand what is the question saying. Okay, did everyone understood?
Yes.
Yes.
Let's go to one more question. This was an exam question. Similar question will be like this in the exam. Read this question. A, B, C, these are independent triple of events. Independent means what? A intersection B intersection C is
Is
phi,
zero.
or A intersection B is phi, B intersection C
I
is
think that
phi.
one is disjoint.
Okay.
If they're independent, means the intersection is the PI times PB
Sorry,
times
sorry.
PC.
Yeah, these are disjoint. I just got confused with this. Yeah, it will be, for example, this part independent means, for example, P of A intersection B will be P
Is
of
P of
A
A
times P
times
of
P
B.
of
Okay, they are not independent means one is independent of the other. Like they are not dependent on one another. So this will be their condition. If let's say there are three sets, A intersection B intersection C, and they are independent, it will be A times B times C. Let's write probability. So probability of A times probability of B times probability of C. Okay. So this is the definition of independent events. So proof that the pair of events, this one is independent. We know that A, B, C are independent. We have to prove that A's complement and B complement are independent. How can you prove this? Proof, how can we prove they are independent? That means we have to show that probability of A complement intersection B complement is probability of
A
A
complement
complement
times
times B
B
probability
complement.
of B complement. We have to show this one, right? To show. Show or to prove. Okay, we have to prove this one. How we will prove? Let's see. A complement intersection B complement. So imagine there are two sets A and B. Okay. And how can I write A complement intersection B complement? This is the whole, let's say, the whole sample space, and inside this there are two sets. Okay. So how can I write A complement intersection B complement? A complement means leaving the set A, whatever is there in the whole world, you can say, whole sample space. Leaving the set
B
B,
complement.
what is there in the sample space. Okay, leaving. Did you understand? The pink is for B part, this is for A part. So what are the common part you got? What are the, where are the common parts, like both black and pink collab? This part, these parts, right? These part, yellow part. So this is A complement intersection B complement. Can I write this one as this one as probability of, can I write this one like this? 1 minus probability of A union B. I just subtract from the whole probability is 1, suppose whole system. So 1 minus A union B, right? Can I write like this?
Yes.
Okay. So can I write like this now? I just apply the formula now. Probability of A plus probability of B. I'm just putting the form bracket minus probability of A intersection B. So I'm opening the bracket. Probability of, okay. So how can you use now? What will you do from here? Just think a bit. Can I write like this? Can I write this one as probability of A times probability of B? Can I write like this?
Yes, and
Yes,
it's
because they are independent, which is already said in the question. So, what should I do to bring my question from here to here to prove? So, let me just take something common from here. So, can I take P of B common?
Yes.
So, I'm taking minus P of B.
It is 1
It will be
plus
1
P of A.
minus 1 minus P of A. Okay. This is 1 minus P of A. So now I am taking 1 minus P of A common. Okay. So it will be this part. So this is 1 minus P of B, right?
P.
So what is 1 minus P of A? Imagine there is a set A, and what is 1 minus P of A?
P of A complement.
Yeah, P of A complement. Same with B, P of B complement. Now, did you prove that P of A intersection B, A complement intersection B complement is this? Okay, are they independent? Yes, independent. Okay, let's go to proof number B. Proof that the pair of events this is independent. So we have to prove that this one. Let me add a page. That is what proof is asking about. We have to prove A union B comma C are independent. Okay, so probability of A union B intersection C must be like this: probability of A union B times probability of C. Is it, am I right?
Yes.
Okay, so how we will prove? Let's see. To prove this one, to prove. Let's prove. Form proof. Probability of A union B intersection C. Um, okay. Can I apply the distributive property? Yes. Probability of A intersection C union
B intersection C.
probability of B intersection C. Okay. So how should I open it now? Apply the union formula. Let's say this is X, this is Y. So how do you apply probability of X plus probability of Y
Minus the
minus
intersection.
probability of X intersection Y? So same thing apply here. Probability of A intersection C plus probability of B intersection C minus probability of A intersection B intersection C intersection B will be A intersection B intersection C, right? Or should I
Yeah.
write it like this? Intersection B intersection C. So if you open this one, it will be, this one will be probability of A intersection B intersection C. Okay. So now what to do? You know that P of A, C, A, B, C, all three are independent. So apply the formula, they are independent. So probability of A times probability of C, probability of B times probability of C minus probability of A times probability of B times probability of C. Now, okay,
P of
now just
C.
think what to take common.
P of
Okay,
C.
take, should I take P of C? Yeah, perfect. Plus, okay, let's take P plus P of B. I'm taking P of C common. P of A times P of B times P of C. Okay, now did you take P of C? Okay, what is this? What is the formula of this?
P of
Can
A
this part,
union B.
can I write this part as P of A intersection B, because they're independent, so I can do the vice versa. So if I write this one like this, so can I write this whole part as P of A
Union.
union B times P of C? Is it correct?
Yes.
Okay. So have we proved this one from this to this? Yes, we proved. Yes. So this is yes, independent. Independent. Okay. You just after applying the formula, just write yes, this pair are independent events. Okay. And let's go to option C. Under what conditions A, B, C are the pair of events this is independent? Okay. So this under what conditions A, B, C, the pair of events these is independent. So we have to check what are the condition and all. Let's see. Mm, let me add a page. It is asking that A intersection C, comma B intersection C must be independent. But we have to also check the conditions of A, B, and C. Okay. So that means the probability of A intersection C, A intersection C, intersection B intersection C must be equal to probability of A intersection C times probability of B intersection C, right? Okay. So
Yes.
we have to prove this part. We have to show or to prove. Okay. So let's prove this. Mm, okay. So probability of A intersection C times intersection B intersection C is equal to probability of A intersection C times probability of B intersection C. Can I write like this? Because A, B, C, they all are independent. Can I write like this? Or shouldn't I shouldn't write because I want to prove like this. So can I write like this? Open this everything. A intersection C intersection
Intersection.
B intersection C.
Intersection.
Let's bring this one here. You can uh, it can be written as probability of C intersection C will be, if I write
C.
like this, C intersection C, this one, B
MC.
intersection C intersection C it will be probability of A intersection B intersection C. Okay. So after this, do I know that all of the three are independent? So I have to write P of A times P of B, P of C, because all three are independent events. Now how to approach from here to here, here to here? How do I approach? How do I prove that I had to prove like this? How do I prove? What are the conditions that I should apply to prove? Think a bit. Okay.
They shouldn't be zero.
Think one more expression of this one. So we got one expression, this one I'm writing. Can I write A intersection C intersection B intersection C? Can I write like this? Probability of everything, everyone is independent. So can I write like this? P of A times P of B times P of C. Wait. P of C times P of B times P of C. I just opened everything because they all are independent. So everyone has the same intersection, 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 intersection. So P of A times P of C times P of B times P of C. So what it will be? P of A times P of B times P of C square, right?
Yes.
So here in 1, you got this one as the expression. But in
Mhm.
2, you are getting this as expression. Both are correct, but how can these two will be equal? How can option 1 equal to option 2? That means P of A, P of B, P of C is equal to P of A, P of B, and P of C square.
P of
How
C
can
is equal
this
to
be?
1 or 0.
How, if P of C is equal to 1, then what will happen? Can
They
you
can be
say?
equal to each other.
But they can be
Because
equal.
the only number that the square, and when you do the square, it's equal to itself is 1.
Okay, what about 0?
Yeah, not 0.
P of, for example, it can be P of C equal to 1. It can be P of C equal to 0. Yes.
Yes.
And what other conditions? What if P of A is equal to 0? So this side LHS, this
Mhm.
is left hand side and right hand side. So will it be if P of A equal to 0? So 0 equal to 0, can it be equal? Yes.
Yes.
What about P of B equal to 0?
Yes.
Yes. So these are the conditions of A, B, and C uh, when the both of the will be independent. Okay. They will be only in the condition if P of C is equal to 1 or 0, and A and B must be 0 to satisfy this condition. Okay, you just need to write these are my condition to satisfy for this condition to be independent. Did everyone understood this part?
Yes.
Yes.
Okay. So we like usually Rajat told me the class hour are 1 hour 30 minutes. Okay. So we can end the class. Let's discuss 5-10 minutes one more question and then we can end the class. And I will share you rest of the question. You have to do it. My target was to do more question today's class, but anyhow we discussed lot of concepts. Uh, let's go to do one or two more question. Let's do this on question one more. It was an exam question from June 2022 second session. Okay, I think we did this question. No, we did
Yeah,
this
we
one.
did.
Okay. This one, let me check. July. Okay, this is July session. Let's do this question. June or July? Let me check. July. Okay. Um. Okay. So read this question for 2 minutes. I'm giving you 1-2 minutes to read. So did you read the question? Like, let
Yes.
me explain. There is a on. Okay, where 5 red balls are there and 3 white balls. Okay. So one ball is drawn. So we have to draw one ball and immediately discard it. Like this is the bag. Okay, 5 red ball and 3 white ball. I draw one ball. Okay, then I throw the ball. It will be lost. I cannot put it inside the bag. Okay, so immediately I discard the ball. Then one ball of the other color is added to the on. So for example, I draw a ball which is red. First time I draw a ball, I don't know what color, but I saw, oh, it's red. Let me throw this ball. So this ball is discarded. Now you will say, okay, I will add one more ball of the other color. So since it is red, I will add a white color. I will add a white color inside the bag. Okay. A second ball is finally drawn from the on. Then you now you have to draw one more ball from the on. And what is, we don't know, it can be red, it can be white, but we have to check what the question is saying. Question is saying compute the probability that the second ball is red. Okay. What is the probability that the second ball is red? And these are the conditions given. So let's think. Okay, I don't know what is my first condition. You say, what should I do? Should I get a white ball or a red ball? Whatever condition I can, but I have to consider both of the condition. So
First,
probability red. Okay, probability of getting a red ball. I'm writing in the sec, since it is said probability of the second ball is red, so I'm writing second ball is red means R2 red. Okay, so my second ball is red, that means the my first draw, let's think about the first probability of first ball red. Okay, so I took out a ball from the bag and I got, oh, it's red, let me throw out. So now I throw. So now I put one more other color ball, that is probability of like the white ball inside the bag. So what should I apply the condition that I should now second time I am drawing and it is saying the second ball should be red. So the second ball should be red, probability of the second ball to be red, given that what I got, my first ball red. Or I can also write, for example, first ball I got white. So probability of white ball, W, let me write W1. Okay, first draw as white ball. So I got the white ball. Okay, oh, I got the white ball. Let me throw it. Now I will add a red ball inside the bag. Red ball. Okay, so but what is the condition saying? My second ball should be red. So probability of second ball red, but what I got in the first time, white. Okay, so what, how I can solve it? So what is the probability of my first ball to be red? I'm just solving this part. How many number of
5
red
over
balls are there?
8.
Sorry.
5 over 8.
Yeah, 5 over 8. Now what is the probability of this part?
4 over
My second ball to be red,
4
if
over
I 4, obviously, because now we have 4 red balls. So 4 over what?
8.
8. Perfect. Because we took, we got one ball red. We threw that ball, but we added one more white ball. So the total number of balls remains the same. Okay. So plus this part. This part, okay. What
3
is the
by
probability
8.
of white ball? It's 3 by 8. Now second ball is red. Imagine first time I got a white. So I threw the white ball. I added a
6
red
over
ball
8.
inside the bag. So it will be 6 over 8. Got everyone understood this question?
yes.
Okay. Now let's go to option B. Okay. Question B. Compute the probability that the first ball is red. Okay, knowing that the second is red. So what is the saying? What should I, you just tell me. This one I will not tell. You tell me what condition is given and what is the probability asked and what is the condition given.
So we know that the second one is red. So P of R2, given that either it could be from uh,
Second one is red. So it is already given that second one will be red anyhow. Okay. But first one, what is the probability that my first ball will be red? So probability is the first one, but given condition is the
mhm.
second one. So
So
can I
P
write
of R1.
R1 given R2, that second ball is red? The probability of getting the first ball as red given condition that the second ball is red. Okay. So think of the condition. I'm not putting the formula, but formula also I can put like this: R2 given R1 times R1. Apply, this is base form rule. Okay, this is the formula and you can get directly, but apply logic. I'm just do by logic. The first ball is red knowing that the second is red. So what is the probability of getting a first ball red? First ball,
5/8.
5/8. Given that the second ball is already red, so what is the probability of the second ball to be red?
4/8.
Okay. And what we should consider the total probability of the red ball, right? Divided by the total probability. So this will be our total probability. We just did what is the total probability of red ball. We have to consider both of the condition, that the total probability of the red ball in the second, like second red ball to be red. Okay. So this one is whatever we got here, which is 5/8 times 4/8 plus 3/8 times 6/8. Okay. Did everyone understood? Just follow the calculation and answer will be something.
Yes.
It is 20/38. Yeah, 20/38. Okay. So did everyone understood option B?
Yes.
Yes.
Okay. So did you also understand, everyone? Like how will you apply the condition?
Part A was a little difficult for me to understand.
Part A.
Yes.
See, part A was something like, see, the compute the probability that the second ball is red. It is saying that, let's say bag. Imagine there is a bag and it has 5 red balls and 3 white balls. First time I say, go the field, take one ball out. You took out, oh, ho, I got a red ball. Now you will throw that ball. Okay. Now you will add a white ball inside the bag. Done. For example, I say you, okay, this one is one condition. You got a red ball in the first time. Now I will say no, no, no. Now you, for example, you, I say, okay, go to the field, take one ball. Not, it is not the second time you are drawing. It is just a probability that what conditions will happen, means what future thing will happen, futuristic. Like tomorrow I will go to university. While going, I will fall down on the road or I will not fall down on the road. It's a probability. Tomorrow it will rain or not rain. So while going to university, it might rain or it might not rain. So both condition you have to write, like probability of going to university and rain. It will rain plus probability of going to university, not condition, times rain. Probability of going to university, probability does not rain. So it can happen. Yes or no? So this is
Yes.
same as this. You go to university, tomorrow it will rain. This condition can happen. Or there will be one more condition also. Probability of going to university and doesn't rain. So it has two conditions. If you say add one more two condition, one more condition, like there will be snowfall, probability of going to university, it will be snowfall or rain, or doesn't rain, or doesn't snowfall. Okay, so this is all about condition. So in probability, whenever you're doing, you have to add all the condition. You have to think that what other possibility can happen. Okay, first time you got a red, but you will say me, what will happen if I got a white? What would have happened if I would have got a white ball? If you would have got a white ball, then you take one ball. Oh, I got white. Throw that white ball. Put one red ball in the bag. Now, what is the probability that the second ball will be red? So the number of red ball has increased. Now the condition is changed from from five red ball to now six red ball. And what is the total number of balls? It's instead of seven, it is now eight because we add one ball. Okay. So in probability, you have to check all the conditions. Let's do the last bit. Did you understand?
Yes, thank you.
Okay. Now option C. Read the option C. Compute the probability that the first and the second ball both are red. So what do you think? Both should be red. We have to find the probability of both the balls to be red. Let's not think
Intersection.
of any formula. Just use your brain. So first ball to be red, just tell me. Intersection, very good. So 4 by 8, right? There are 5 red balls, so 4 by 8, sorry, not 4 by 8, 5 by 8. 5 red ball, okay, red ball. So 5 red ball, it will be 5 by 8. What is the second? I will get the red ball. I got a red ball.
4
So
by
this
8.
red ball will be discarded. Add a white ball. So it will be
By
4
8.
by 8. Okay.
Mhm.
But I'm adding one more question. Okay. What will happen? Okay. Compute the probability that the first ball is red and second ball is white. So how will you compute this one? First ball red means 5 by 8, right?
Yes.
Second ball white. Just tell me what I will get. In the second draw, I got a white ball. What is the probability that in the second time I will get a white ball?
4 by 8.
No. Four. Yeah, three white ball. Yeah, 4 by 8. Yes. Okay. Similarly, one more also can be then first ball to be white and second ball to be, what is the probability of the first ball to be white and second ball to be red? Can you say first ball white? 3
3
by
over
8.
8
Okay, times
times 6 by 8.
6 by 8. Read the question again. 6, yeah, 6 by 8. Okay. Did everyone understand when we have to multiply and when we have to add? Did everyone understand? Like sometimes we are multiplying and sometimes we are adding. Like here, see this part.
Yes.
Okay. Did you understand, Gordafed, about the
Yes.
condition part when you have to add?
The time that
Add,
it is
yeah,
saying the specific wait, a specific situation is happening, it's multiplication. But
yeah,
when you have to consider the everything that can happen
conditions.
is a
Yeah,
union and
it's,
you plus sum them
yeah,
together.
yeah. Yes, yes.
Okay.
Whenever there is a or condition, this can happen or that can happen or that can happen. We add.
Mhm.
Okay. Whenever we have to consider both of the condition, like first time we have to take a ball, second time we have to take a ball. So we have to consider both of the condition. We multiply. Okay. See, this is all about today, but I will share you some question. I had here also one question from this one, and there are two three like some question, and I will say give you a set of questions similarly whatever we did the question today and what concepts we cover, everything you will get a question and you just practice the question. No need to like go much detail into the derivation part. No one is going to ask you prove this prove that. Just only this part you will apply your logic, basic things you have to apply. The conditions are given and you just prove. Okay, for example, what will happen for A? These are the conditions which are given. A union B given C. What can you write this one? As I taught you, A union B intersection C divided apply multiply is divided by P of C, right? If,
Yes.
am I right? Okay. So what can you do this for this one? Uh, just okay. Open it. They apply the distributive property. Okay, intersection A intersection C plus sorry union probability of B intersection C divided by P of C. You have P of C. Okay. You have
P of
to
B and P of C are equal,
you
so
have this one also. These are the condition. A intersection B is phi. Okay. But you don't know these are the condition. No. You cannot apply like this.
B intersection C, because they're equal, is P of B or P of C. Couldn't be.
Sorry. What did you say?
B intersection C, because P of B is equal to P of C, and the intersection is itself and one of them. So it can be P of B or P of C. Cannot be.
Yeah, you're right. So as for this condition, you can write P of C. Or P of
Mhm.
B, anyone, but I'm writing P of C because we have a C here.
Yes.
So
Mhm.
if you write A intersection C union P of C by P of C. Mm, okay. No, I
And
think
then
there
we
should
write the
not be a
exclusion
P
in
here.
each book.
Okay, there shouldn't be P here. It will be union C. Yeah. So just apply this like this A intersection okay intersection C union C by P of C. You got like this somehow like this. Um okay, we have to think how to use this formula. I think we cannot approach like this. A union A intersection C. No, we cannot like open. We have to open it. This one, let's open it. Like imagine this is one set and one set. So apply the full formula and open it. A intersection C plus P of C minus P of A intersection C intersection
Section
C.
C.
Okay, so it will be C, A intersection C
Mhm.
divided by P of C. So
And
what
in
it
one
will
of the conditions, I think it O intersection C, it
okay.
was 0 or no?
Yeah, yeah. Can you write? Okay, we have to bring because we know this one, this one, this one, this one, but we don't know what are the values of this one. Okay, so but it is going to be one.
Yeah.
See, because this cancelled and it is going to be one. I don't think the answer will be one. Did some mistakes. Okay, let me rub. This is not the correct process to approach. Mm. Okay, let's think like the way it is given. Like what are the thing we have intersection equal to this and this. A union B. Whenever you don't understand, just draw the Venn diagram. Okay. A union B given C. Randomly, just draw it just to figure it out. Um, can I write this one as A given C? I'm just opening the union one plus probability of B given C minus probability of A intersection B given C. The C part remains the same, just A union B part I'm opening it. Is it the same thing what I'm writing? It's the same because in conditional probability, this part is fixed. Okay, the condition is fixed, so you can apply this formula. Okay, so you have A, this one you have. Do you have this one? No, you have
It's
probability
1
of,
minus
we have
1 minus
probability
P
of
of B
B.
given C.
Maybe we have to see. Probability of B given C is, we don't know this one, but we know this one. C given B, which is already given in the question 1 by 3. One more condition is given, probability of B equal to probability of C. So do one thing, this one apply multiplication rule. I can write this one B intersection C divided by P of C, right? So this one, since it is intersection, so what will happen? P of C by P of C. Is it 1? 1 or not? If they both are equal, it will be 1. That means,
Uh-huh.
can I
Yes.
write the, since it is 1, so same thing. This one will be, no, it cannot be 1. Let me check. It will be equal to that. Okay, just a minute. Mm, it shouldn't be, it can be 1 also. Okay, P of, okay, I'm just not putting the value of intersection here. Okay, let's keep this condition 1. Okay, now see, if I write probability of C given B, how can I write this one? Probability of C intersection D by P of B, right? Okay,
Yes.
let's, and you know that C intersection B is same as probability of C intersection B is same as probability of B intersection C. Yes or no? This is condition 2 and okay. But is in my question, in question it is given that P of B equal to P of C, right? So can I write this one as P of B intersection C by P of B? Isn't the same as this one? So
Yes.
what did I prove? Hence, P of B given C is same as P of C given B. Okay, that is equal to 1 by 3. Okay, now you got 1 by 3. Put here. You know this because it is given in the question. You know, got this because we proved that these both are equal. So this is 1 by 3. This is 1 by 4. And what is the value of this? Okay, we have to find the value of this one. What is A intersection B given C? What do you think? A intersection B is 5.
So it's 0.
0. This one is 0 because A intersection B is given 5. So probability of A intersection B, whatever the condition is given, it will be 0. So what is the answer? 1 by 4 plus 1 by 3. It is how much? 7 by 12. Okay. Did everyone understood?
Yes.
Okay. I will also share you the question and the solution, everything. Okay.
Thank you.
Okay. See you in next class. Maybe tomorrow we will do the class in the evening. Okay. And
Yeah,
tomorrow
okay.
we will study about the probability density function, mass function, all these concepts. But before that, finish all those extra questions. Okay.
Can
Thank you.
Sorry.
the warehouse, there is a chip, one of them is affected, another is ineffective. That one is the most difficult, I think.
Warehouse.
Yeah, it's about the chips which you want to sell them, and one of them is defected. I will send it to you.
Okay, just send me.
Okay.
Okay. Bye bye.
Bye.
Goodbye.
Bye.